Last episode, we got reads down to almost nothing. The cache answers before the database even hears the question. But we left on the other half of the story. You tap place order, and now you're just sitting here. 4 seconds watching a wheel spin because the app is doing all four of these jobs one after another before it'll even tell you it worked. But only one of those four actually needs you to wait. So, what if we stop making you? Look at the four jobs. Charging the card, that one you have to wait for. If the payment fails, you need to know right now before the screen says confirmed. That's the whole point of paying. But the other three, telling the restaurant, sending your confirmation SMS, pinging the delivery app, none of those need you standing there. They just need to happen soon, reliably, but not in the half second while you're staring at a spinner. That split has a name. Work you wait on the answer for is synchronous. You met the word back in episode 8 when copies could be sync or async. Work you fire off and move on from is asynchronous. The trick to a fast app isn't doing less work. It's being honest about which work the user actually has to wait for and getting everything else off their path. So, how do you get work off someone's path without just dropping it? You write it down and you put it somewhere, it'll get picked up. Picture the pickup counter at a busy takeaway place. When an order is placed, nobody makes the customer stand at the pass while it cooks. The order gets written on a slip, the same order slip from episode 6, and dropped on the shelf. The customer's hands are free. They can go. That shelf is a queue. The app writes the job down, drops it on the queue, and immediately tells you done. Because the part you cared about, the payment already cleared. The slow stuff is now sitting on the shelf, waiting its turn. The order still gets handled, just not while you're watching. That's the whole idea. Placed now, handled later. Now watch who's doing what. The app that dropped the slip on the shelf, it never cooks. It writes the order and walks away. We call that side the producer. And whoever picks the slip up and actually does the work charges nothing, just cooks, notifies whatever the job is. That's the consumer. A worker that pulls a parcel off the shelf, handles it, and reaches for the next one. And here's the beautiful part, the producer and the consumer never meet. They don't even have to be awake at the same time. The worker can be slow or busy or crash and restart. The parcels just wait safely on the shelf until someone's free. The two sides are decoupled. And if the shelf is filling faster than one worker can clear it, put more hands on it. Two workers, three, each grabbing the next free parcel. One shelf, many workers, every parcel handled exactly once. Remember the food rush from episode 3? A lakh people ordering at 8 p.m. Back then, when demand outran the kitchen, a queue formed against us. Orders stacked up, and every extra second of waiting was pain. Same picture. But now the shelf is on our side. The rush hits, parcels pile up on the shelf, and that's fine. The shelf just holds them. The workers keep pulling at their own steady pace, and nobody upstream is blocked. The queue absorbs the spike instead of collapsing under it. This is exactly how Razorpay survives an IPL match. Their traffic can jump from 200 requests a second to 1500 in seconds the moment a wicket falls and everyone pays at once. Part of how they take that hit is moving work off the live path and onto a queue to be handled as fast as the workers can without making anyone wait. A queue turns a terrifying spike into a manageable pile. That's the shock absorber. Now, a hard question that sounds simple. When the worker takes a parcel, when exactly do we cross it off the shelf? Because the answer is the whole game, and there are three of them. Option 1, cross it off the instant a worker touches it. Gone from the shelf immediately. This is at most once. It's fast, there's no bookkeeping. But if that worker fumbles it, drops it, crashes on the way to the kitchen, The parcel is just gone. Nobody's coming back for it. And sometimes, genuinely, that's the right call. A user is typing dot, one reading on a live metrics dashboard, a single frame of a location ping. Lose one, and nobody on earth notices or cares. When the data is cheap and constant, at most once is perfect because you paid nothing for it. Option 2. Leave the parcel on the shelf until the worker confirms it's done. Only then cross it off. This is at least once, and it's the honest default almost everywhere. Nothing ever gets lost because the shelf won't let go until someone says handled. But there's always a but. What if the worker did the job and then crashed before the confirmation got back? The shelf never heard done. So it hands the parcel to another worker. And now the same order gets processed twice. Option 3 is the one everybody wants. Exactly once, handled once, never lost, never doubled. Perfect. And the honest truth, the whole industry dances around as a delivery guarantee. It basically doesn't exist. Nobody can promise the message and its effect happen exactly one time across every crash. What they sell as exactly once is really at least once underneath, plus a worker built to ignore a repeat. So the real world runs on at least once, which means duplicates aren't a bug you avoid, they're a fact you plan for. So the same order can arrive twice, which should terrify you for exactly one reason: payments. Remember way back in episode 2, the warning about tapping pay twice and paying twice. This is where that ghost comes back. Now, the obvious fix. Before you do the work, check, have I seen this order before? And that mostly works. But watch what happens when two copies arrive at almost the same instant. Both workers ask, have I done this one? Both hear, nope. Because neither has finished writing down that they're doing it yet. And both charge the card. The check raised itself. Making a job safe to run twice, truly safe no races, is its own genuine problem with a name, idempotency. And it's such a good problem that it gets its own episode. Retrees, idempotency keys, why double tapping pay doesn't pay twice. For today, just hold the shape. At least once gives you duplicates, and idempotency is how you survive them. Two more sharp edges because a shelf isn't magic. First, order. A physical shelf is a free for all. A worker grabs whichever parcel. Usually fine, but sometimes order is everything. Say order created and order cancelled land close together, and a worker happens to grab cancelled first, then created. Now you've got a cancelled order that just got recreated. A ghost order alive again. The fix is to stop using a free for all shelf and use a line first in, first out, a proper queue where parcels come off in the exact order they went on. But there's a cost, and it's the same one from the sharding episode. A strict line means one worker at a time for that order. Keep the order or spread the work. You rarely get both. Second edge, the parcel that cannot be handled. Corrupt data, a bug, a job that fails every single time. On an at least once shelf, that poison parcel comes back, fails, comes back, fails forever. And worse, it jams everything behind it. So you give it a timeout. Try a few times, and if it still won't go, lift it off the main shelf and set it aside on a special one. A dead letter queue. The poison parcel gets quarantined. A human looks at it later, and the line keeps moving. Everything so far has one shape underneath it. One parcel, one worker, the job done once. That's a queue, and it's most of what you'll ever need. But there's a completely different question hiding in our order. When you place that order, it's not just the kitchen that cares. The restaurant needs to know. Your SMS receipt needs to go out. The loyalty points need adding. The fraud check wants a look. 5 different services all needing to hear about the same event. And a shelf can't do that. A parcel gets taken by one worker and then it's gone. If five services each need it, the shelf hands it to one and starves the other four. For everyone needs to know, you need a different tool entirely. So stop handing the event to someone. Announce it. Picture the expo at the pass who calls out when an order's up. Table 12 ready. And everyone who's listening hears it at the same moment. The runner hears it and moves. The waiter hears it and clears the table. The kitchen display hears it and updates. One shout and each of them reacts on their own, in their own time, without waiting for the others. Nobody's handed anything. They all just heard the same thing. This is publish and subscribe PubSub. One site publishes an event to a topic, and every service that subscribes to that topic gets its own copy. Reading it doesn't use it up. Add a sixth listener next year, a new analytics team say, and they just subscribe. Nobody else even notices. And here's the line to burn in, because people mix these up constantly. A queue is a takeaway shelf. One parcel, one worker, the job gets done once. PubSub is a callout. One shout, and everyone who's listening hears it. Q is for getting a job done. PubSub is for spreading the news. PhonePe runs this at a scale that's hard to picture. Around 100 billion events a day flowing through this kind of pipe, so that one payment can quietly light up your receipt, your history, your rewards, all at once. These shelves and callouts have real names, and you'll hear three constantly. Meet them once so they're not scary later. Kafka is the giant. Technically, it's not a shelf at all. It's a log, a running record that keeps every message instead of deleting it when it's read. Which means a brand new listener can show up and replay the entire history from the start. LinkedIn, where it was born, moves around 7 trillion messages through it a day. RabbitMQ is the classic queue, the flexible router. It's brilliant at exactly the shelf and worker job we drew all episode. Take a message, route it by rules, hand it to a worker, retry it, dead letter it. When people say message queue, this is often the shape in their head. And SQS, Amazon's queue, is the one you reach for when you want none of the running of it. Fully managed, it just exists in the cloud, absorbing your spikes while you think about literally anything else. Different shapes, same core idea. A place to put work. So the person who made it and the person who does it never have to wait on each other. Misho runs an order pipeline like this, handling roughly 3 million orders a day. So put it together. Some work has to happen, but not while someone's watching. So you write it down and hand it off. A queue is a takeaway shelf. One job, one worker, done once, and the spike just piles up safely until the workers catch up. Pubs up is a call out. One event and everyone who's listening hears it. And the cost we took on, honesty about duplicates, about ordering, about the parcel that won't go. A whole new set of things to get right, in exchange for never making the user wait. But look at what we just did to our nice simple system. A moment ago it was one app. Now it's a producer here, a pile of workers there, five services all listening for events, a dozen little pieces each with its own address, all talking to each other. So when you've got a dozen services all calling each other directly, who does the outside world even talk to? Who guards the entrance, checks the pass, points each request to the right place? That's a brand new kind of problem, and it's where we go next.